Black holes, those enigmatic cosmic entities, continue to captivate our imagination with their mysterious and perplexing nature. While we know that nothing ever escapes a black hole's clutches, the question that beckons us to explore further is, what lies within these dark abysses? As we delve into the depths of the universe's most enigmatic phenomenon, we uncover the tantalizing secrets of black holes and the intriguing journey of discovery that has brought us closer to understanding their true nature. For centuries, the concept of black holes remained a mere speculation, a figment of scientific imagination. The idea of objects with gravitational fields so potent that they imprisoned light within their grasp had been contemplated since the 18th century by some of history's greatest scientific minds. However, it wasn't until Albert Einstein introduced his revolutionary theory of general relativity in 1915 that scientists gained the tools to calculate and describe these cosmic phenomena with precision. Still, black holes remained elusive, residing only in the realm of mathematical abstraction until the 1960s, when Stephen Hawking popularized the concept and piqued the curiosity of the scientific community and the world at large. Discovering black holes proved to be a formidable challenge. Unlike other celestial objects that could be directly observed, black holes revealed themselves through their effects on surrounding matter. Gases and stars in proximity to a black hole behaved in ways that defied the laws of conventional physics. They emitted high-energy radiation that remained invisible to the naked eye but could be detected using specialized telescopes and tools. Through reverberation mapping, scientists could measure the radiation emitted by a rotating disk of debris encircling a black hole, allowing them to pinpoint its location even when the black hole itself remained shrouded in darkness. Then, in a monumental breakthrough in 2019, scientists achieved the seemingly impossible. They captured an image of a black hole using the International Event Horizon Telescope, providing humanity with its first tangible, photographic proof of these cosmic enigmas. Although the image portrayed the black hole's shadow, as the black hole itself does not reflect light, this achievement would have astounded even Einstein, who couldn't have envisioned such a feat just a century ago. The mass of a black hole varies, ranging from the tiniest ones, possibly as small as a single atom, but with a mass equivalent to a large mountain. And then, there are the supermassive black holes, found at the heart of every galaxy, with masses exceeding that of 1 million suns. Now, let's engage our curiosity and embark on a hypothetical journey. If, by some cosmic twist of fate, our sun were to transform into a black hole while maintaining its mass, would Earth and the rest of our solar system be doomed to spiral into oblivion? Surprisingly, the answer is no. The black hole's gravitational pull would remain identical to that of our sun, even though its size would be vastly smaller. The Earth and its celestial companions would continue their orbits around this newly formed black hole, though the familiar warmth and light we receive from our sun would be conspicuously absent. Fortunately, our sun lacks the necessary mass to ever collapse into a black hole, sparing us from such cosmic turmoil. Given our ability to glean so much about black holes' formation, properties, and behavior, even before we captured their image, we might wonder whether we can fathom what lies within these cosmic mysteries. While no one who enters a black hole could possibly report their findings back to us, scientists have developed compelling hypotheses about the interior of these enigmatic entities. The closest black hole to Earth resides more than 1,000 light-years away, making it an unattainable target for exploratory missions in the foreseeable future. However, let us indulge in a hypothetical scenario and consider what the intrepid pioneers might encounter inside a black hole. Approaching a black hole would be a unique experience, unlike any other celestial body. As one drew nearer, there would be no direct visual confirmation of their proximity to the black hole itself. The exterior of a black hole exerts its influence on objects in its vicinity, allowing explorers to discern their proximity by observing the behavior of surrounding matter. As they ventured closer, they would encounter a threshold, an invisible boundary known as the event horizon, the black hole's final frontier and the point of no return. The plunge into a black hole is not an instantaneous affair. An intrepid explorer would have a fleeting moment to contemplate their surroundings before reaching the singularity. The duration of this journey varies depending on the size of the black hole. For smaller black holes, equivalent in mass to a few suns, the descent would occur in the blink of an eye. In contrast, within a massive black hole millions of times more massive than our Sun, the explorer would have several heartbeats worth of time to absorb the surreal surroundings. These precious moments would seem like a surreal voyage into the realms of science fiction. In the universe beyond a black hole, objects and beings are free to traverse in any direction, exploring the three-dimensional expanse. However, they remain tethered to the inexorable flow of time. Inside the event horizon, an entirely different reality prevails. Here, there is only one direction to travel, towards the singularity. Regardless of an explorer's chosen path or orientation, the singularity looms perpetually ahead, an elusive yet omnipresent destination. Simultaneously, it remains perpetually out of reach, a tantalizing enigma. As the daring voyager continues their descent beyond the event horizon, they would notice a surprising contrast to the expected darkness. Instead of an inky void, they would find themselves enveloped in light from the surrounding universe, a cascade of light that shares their doomed trajectory into the black hole, unable to escape its grasp. The extreme gravitational forces within the event horizon distort and warp this light as it hurtles towards the singularity, creating mesmerizing visual phenomena. Yet, it's not just light that is subjected to the gravitational whims of a black hole. The explorer's own body would experience the relentless tidal forces exerted by the black hole. These forces would act unevenly on different parts of the body, squeezing it at the midsection and stretching it from end to end, a phenomenon aptly named spaghettification. As the body elongates, the infalling light would congregate into a luminous band encircling the explorer's waist until both the body and the light lose all semblance of dimensionality. The explorer, now an elongated ethereal form, becomes a part of the cosmic ballet within the black hole. Amidst this mind-bending display of physics-defying acrobatics, the explorer would encounter yet another bewildering occurrence: time dilation. As they plummet towards the singularity, the universe outside the event horizon would appear to accelerate, racing forward at an accelerated pace. It would seem as though time itself were escaping their grasp. To an observer positioned outside the black hole, the explorer's descent would appear quite different. As the explorer approached the event horizon, they would perceive a gradual slowing of their movements, almost as if they were frozen in time, rendering it nearly impossible to discern their ultimate fate. Finally, when the brave voyager catches a fleeting glimpse of the singularity, they would encounter a paradoxical emptiness. The singularity would present itself as an expansive, featureless, and incomprehensibly vast black plane, stretching endlessly in every direction. At this juncture, the explorer's body, now stretched and distorted beyond any recognition, would undergo an irreversible transformation. It would be compressed into an infinitesimal point of infinite density, dissolving into the singularity, never to be seen or heard from again. Everything the explorer witnessed and experienced within the black hole would vanish into the void, forever beyond our reach. Despite the profound mysteries concealed within the black hole, external observers might still attempt to communicate with the intrepid explorer. They could send signals, perhaps desperate attempts at rescue, into the black hole's depths. However, these signals would meet the same fate as the explorer's body, engulfed by the singularity, forever lost to us. Even if, by some extraordinary circumstance, the explorer within the black hole were to receive these signals and attempt to respond, the relentless gravitational pull of the black hole would ensure that no information could escape its clutches. Thus, any secrets or knowledge the explorer brought with them into the black hole would remain secure within its impenetrable grasp for eternity. Despite our deep understanding of black holes, our comprehension of what lies within a black hole remains grounded in mathematical theories and conjecture, awaiting the day when technology advances sufficiently to grant us a glimpse inside and the chance to return with newfound knowledge. While that day may appear distant, the ever-evolving landscape of science holds the promise of surprises that could hasten our journey into the enigmatic heart of these cosmic wonders. Thanks for watching, and if you enjoyed this video, make sure to hit the like button and subscribe to the channel for more content.